There we go. Alrighty, so my name is Aidan, and I'm just going to give a quick little introduction about me before we get started with this class. So, if it'll let me, give me 1 second. Oh, I see. Um, okay, I'm not sure why it's not letting me full screen it, but we'll do it like this. So, my name is Aidan, and I currently just graduated from the University of California, Berkeley, where I pursued mechanical engineering. So lots of math. I love math. I'm very excited to teach you guys some integrated three. So this is some trigonometry, a little bit of pre-calculus, and we'll go through just a nice little introduction to this course. Um, when I was younger, I wanted to be an astronaut. So I stayed at Berkeley for the past year getting my master's, which was super exciting. Some other cool things. I love to travel. I was super fortunate the past 2 years. I got to go with my friends to Japan where I skied in Niseko, which was super awesome. I tried Michelin star sushi, which has ruined sushi for me. I'm not sure if either of you are Game of Thrones fans, but I went for my graduation trip to Croatia and kind of the Balkans. And the actual Iron Throne from Game of Thrones was donated since they filmed everything there. Allegedly, it was the actual Iron Throne. It was kind of weird. It was just sitting in a cave, not like a museum or guarded at all. It was just there. I mean, I guess it was on an island, but that was a very interesting experience. I love robotics. When I was in high school, I was president of our school's FRC team. At Berkeley, I've done lots of fun projects. I taught a robot to play chess. I built some battle bots. And then yeah, just a couple other quick fun facts about me. I worked at Tesla for a little bit where I built the tools that build the cars. I've been a part of a child brain development study since pretty sure before I was born. So they've been taking pictures of my brain for a pretty long time, which is super cool to see. I like the outdoors. I love exploring. I'm a big music goer, so I like going to music festivals. And like I said, I love to ski. My uncle's a ski coach, so he taught me when I was very young. But yeah, that's just a little bit about me. Before we begin, if you each want to introduce yourselves, you can say as much or as little as you like. Obviously, I had a little time to prepare. But yeah, if Issa, if you want to go first.
Hi. Uh, um,
It could be about anything, maybe um, some hobbies, what you're looking forward to this summer, anything at all.
um, I go to Castro Valley High, and um, I'm working at a few camps this summer, and um, I like to play music.
Nice. What kind of music do you like to like? You play like instruments or
Yeah, I play the piano, violin, and guitar.
oh, super cool. I wouldn't say I'm that good, but I can play the guitar a little bit. The other two, not at all. Masha, would you like to introduce yourself?
I'm going into my sophomore year at Castro Valley High, and I like going to the beach and surfing.
Nice. And then it sounds like you both have a similar job this summer where you're lifeguarding. So super cool. And we'll meet Helena next session. But yeah, so let's before we begin, I just like to say this to everyone. You guys are my boss in the sense that if something doesn't make sense or you want to go over something or you just have any questions, feel free to stop me at any point. Ask me any questions at all. There are no dumb questions. And the chances are if you have a question, someone else might. So definitely ask me questions. This is your guys' session. So if there are things that really don't make sense, let me know. I will do my best to ask you guys questions a lot to make sure that things make sense, but feel free to hop in whenever. Otherwise, it's okay to make mistakes. I'm gonna probably make mistakes. I've been making mistakes for a while. It's a part of learning. And yeah, so let me share my iPad screen and then let's talk about what we're going to work on for today. So give me 1 second while I pull this up. And then at the end of our session, I'll talk a little bit about homework, and I'll show you the Google Drive just so that everything is clear where everything's stored. But yeah, so let me know if you guys can see my iPad screen and what I'm writing. Just like a thumbs up, or is everything appearing on the screen? You can hear me, see me? Awesome. All right. So let's talk about the very first section of this class. So we'll call this section 1. And this is our basic trig functions. And we have a little acronym that we use to memorize these. And you might have been introduced to this before. So if it is, it's review. If not, then we'll go over it. But the first one is so. Second one is ka. And the last one is TOA. And these are a quick acronym for us to memorize our 3 basic trigonometry functions. This is sine of, we'll call this theta. Theta is some angle. Sine of this angle is equal to, we'll call this opposite over hypotenuse. And we'll talk in a second about what I mean when I'm saying opposite, hypotenuse, and theta. Second one is going to be cosine. And this guy is our adjacent over hypotenuse. And the last one is tangent of theta. And this is opposite over adjacent. And what am I talking about? These are all functions, meaning they take in an input. That input is an angle. And we are referring to the angle on it doesn't have to be a triangle. This is just any angle. But what we're talking about over here are the sides of a right triangle. So can you, Isa or Masha, whoever knows it, can you tell me what is a right triangle?
It's a triangle with a right angle,
Mm-hmm.
just one right angle.
Yeah, and that would be a 90-degree angle. And over here, let's call this angle theta. Doesn't matter which one, but let's call this one theta. And we're going to label some things. The side that is opposite from theta. Do you see how this is some angle right here? And the side that's opposite from it, we're going to call that our opposite side. So right here is our opposite side. The side that is next to theta, and when I say side, I mean these sides that share the 90-degree angle. These are the legs. Sometimes we call these legs of our triangle. These legs right here are the sides that we care about. This is the opposite side, and this is the adjacent side, the one that's next to theta. The last one is what we call our hypotenuse, and this is the longest side of our triangle, of our right triangle. The hypotenuse is always the longest side. It is also the one that is across from the 90-degree. Okay? And each of these functions allows us to describe different ratios. Remember, what's a ratio? Ratio is one number divided by another number. Different ratios of the sides of our triangles. That's what each of these functions represents. All right, let's do a basic example of why these functions matter and what we're actually talking about when we're saying to solve these kind of problems. And so far, does everything make sense? Okay, awesome. So the very first example is going to be when x is on top, or when x is our opposite side. And let's say we have this little right triangle right here. That's a right triangle. And we're told that this angle right here is 33 degrees. We're told that the hypotenuse is 18 whatever units, inches, meters, or just 18 long. And on the other side is x. And we want to know, what is x? How do we find x? Well, we go to one of our 3 trusty functions and we ask ourselves, all right, what do we have? Well, we have an angle. All of these use our angle. We have an opposite side. This guy right here is opposite. And we have our hypotenuse. Oops. Masha, can you tell me, with these three things we're given, which one of our functions should we use? Which one can we use that's going to have an input of an angle, we have an opposite side, and a hypotenuse?
Sine.
Exactly. And we're going to write it like this. Sine of 33 degrees is equal to that opposite side, x, over that hypotenuse, 18. Isa, how would we solve for x from this? What would x be equal to? You don't need to plug anything to your calculator yet. Just what do I do to isolate x?
Like you move it to the other side.
Yeah, so I multiply both sides by 18. Multiply 18 here, multiply 18 here. And what am I left with? These 18s go away. So x equals what? Isa?
Like
Hmm?
x equals 18 sine of 33.
Exactly. 18 sine of 33. Now from here, this is where we plug it into our calculator. And do you guys know how to use your do you have a TI-84? Do you have like a graphing calculator that you use?
Yeah, I have one.
Okay. Do you feel like you know how to input an angle into sine? Have we done that before, or would you like me to walk you through that?
Yeah, I've done it before.
Okay, awesome. What about you,
And
Ethan?
two.
So can you both type in and make sure, what do we need to make sure, since we're told this is 33 degrees, what do we need to make sure about our calculator?
You have to be in degrees mode.
Yeah, so make sure we're in degrees mode, and can you both do this? And then when you're done, let me know what that becomes. So what is 18 times sine of 33? The only reason I ask is because I don't have a TI-84 on me right now, and I realized that I need to re-download the app. So I just wanted to make sure I'll have it for next time when we do our calculator, but I want to make sure that you guys are able to get that. And I will make sure I'm in degrees. And let me know what we get.
I got the same thing as you.
Awesome. About 9.8. Let me get a thumbs up if that makes sense and that worked. Awesome. All right. So that is kind of our basic problem. That's what we're going to be doing. And let's do another example. So this time, let's move where x is. So for this example, x is going to be on the bottom, or what we call the adjacent side. All right. So we have or sorry, not the adjacent side. This one, x is the hypotenuse. Oops. And when I'm saying on top here, I mean top of the fraction. And when I'm saying on bottom here, it's going to be the bottom of the fraction. So let's say we are given this guy right here is 17. This guy right here is 14 degrees, and x is our hypotenuse. So, Masha, can you tell me, or Isa, whoever wants to answer, can you tell me what trig function we're going to use now?
Cosine.
Exactly. So can you tell me what would that read out as? So cosine of what?
Cosine of 14 degrees is 7 equals 17 over x.
Exactly. 17 over x. Okay. So what do I do here? What would be my next step? I want to solve for x. What can I do? How do I make x by itself? There might be a couple steps. Can you tell me what the first step might be? What would be your first step?
Maybe multiply both sides by x and then divide it by cosine 14.
Yeah, exactly. We can multiply both sides by x, and then we can divide both sides by cosine of 14. And that's going to move this guy over here by itself and that guy over there. So that gives us x cosine of 14 equals 17, and then we divide it, so x equals 17 over cosine of 14 degrees. Alrighty, can you both plug 17 and divide it by 14 or cosine of 14 degrees, and let me know what we get for that.
I got 17.52.
Perfect. Isa, did you also get 17.52?
I did.
Perfect. All right. So let's move on to the last kind of, the only other type of problem you can get is we can get the exact same thing here, but x is here instead of here, and it would be the same thing but with cosine. And we could get the same type of problem here, but where the angle, the side that we're given is over here, and it would be the same thing with side. Does that make sense? So the only other type of problem we could be given is when x is the angle. So let's ask ourselves, what do we do in this case? So we have our right triangle, and we're told that the opposite side is 8, the adjacent side is 17, and x is our angle. Can someone tell me? So this is our opposite side. So opposite from our angle. This is our adjacent side. Can someone tell me what trig function should we use now?
Tangent?
Yeah, and Isa, what would I write? So tangent of what?
Is it like, what was it, like negative 10?
You're on the right track. But
Wait,
before we do that, we're just going to set up tangent of the angle, right, which is x, is equal to what? What do we remember about tangent? Let's look back to our big acronym.
um, 8 over 17.
Yep, opposite over adjacent, so 8 over 17. And you made a very, very good point. So I told you that these are functions. And if I want to get the thing inside the function, anytime, like if I told you, right, f of x equals, let's say, y, how do you go from f of x once you input, right? I put in a number in here, I get a number out. How do I go backwards? What if I want to know what my original x was? We do something called the inverse of a function. And all of our trig functions have inverses. So if I want x here, I need to do inverse tangent of both sides. So have we seen this before? You might, I don't know if you've heard this term. Some teachers call it arctangent, but this is just another name for inverse tangent. We're going to use inverse tangent since that is a little more accurate to what it is. Have we heard this before? Is this ringing a bell? Give me a thumbs up if this is something you've heard maybe before. Okay. And do you know how to, on our calculator? So when I do inverse of this side, that's just x. And this is going to be inverse tangent of 8 over 17. Can we try and do this on our calculator? There's a little key, like a shift key or a second key. It depends on the model. Sometimes it's called second key. Sometimes it says shift. And it will, above sign, will be a little text that says sign -1. That's our inverse function. So make sure you press the shift key and then we press that. And let me know if you're able to get what this guy is equal to. And I'm going to call it something different because Desmos uses the old name, but this is the same thing. Let me know what you get.
I got the same thing as you.
Perfect. And then just remembering, if this is in degrees, well, then what's the output of this? Remember, it's the angle that's being outputted. So this is going to be in degrees. And if it's in radians, that would be in radians. All right. So does this kind of section one make sense? So let's just quickly recap. Can one, either Isa or Masha, can one of you tell me what is sine? So what do we know about sine? Sine is equal to what?
Opposite over hypotenuse.
Perfect. What about cosine?
Adjacent over hypotenuse.
And then the last one, tangent.
Opposite over adjacent.
Perfect. That is everything from this first unit that we kind of have to memorize. The next thing we're going to talk about is, so we'll call this section 2, and this is going to be our reciprocal functions. So there in this class, there are 6 main trigonometry functions. You've learned about the first 3, sine, cosine, and tangent. And each of those have their own reciprocal function. So this is obviously opposite over hypotenuse. This is adjacent over hypotenuse. And this is opposite over adjacent. What does the word reciprocal mean? Have we heard that before?
Like they're switched around.
What switched around? You're on the right track.
The numerator and the denominator.
Yeah. For example, if I have a fraction a over b, the reciprocal of that fraction, the reciprocal would be b over a. Another way to say reciprocal is if I have the number a, it could be a fraction. The reciprocal of this is 1 over that thing. Why? Well, because 1 over this is the same thing as saying, right? Anytime you do anytime you do something divided by a fraction, that's the same thing as that something multiplied by its reciprocal. Does that make sense? So 1 divided by anything is the definition of a reciprocal. But what does it mean? Like literally, it literally means flip your fraction upside down. Okay. So sometimes you'll see this is a reciprocal, or it's just flipping your fraction upside down. That is what a reciprocal is. But what does that mean for us? Well, each of these has their own reciprocal. If I want to know what 1 divided by sine is, or that's the same thing as flipping the fraction, that's hypotenuse over opposite, this has a special name. We call this the cosecant function. Okay, so cosecant is equal to 1 over sine, and that's equal to hypotenuse over opposite. And let's move this over a little bit. That guy is called our cosecant function. Okay. The same thing goes for our other 2 trig functions. Cosine has one, which is called secant of theta, and that's the same thing as 1 over cosine of theta, which in this case is hypotenuse over adjacent. And this guy is secant. And the very last one is cotangent of theta. This guy is obviously 1 over tangent of theta, and it's the same thing as adjacent over opposite. And we call this guy cotangent. Let me know when you've got that. Give me a thumbs up if everything makes sense so far. Good. Awesome. So, one thing I like to kind of just memorize, kind of annoying, but sine and cosecant go together. So I just remember that it's opposite. The reciprocal function is an opposite letter, and cosine and secant go together. I'm going to introduce one other thing that's going to be a little more useful a little later in the unit, but I want to introduce it now. And tangent is equal to something else. It's Let's take a look at something. I'm going to tell you the tangent is equal to sine divided by cosine. But I want to prove that first. And super easy to prove. Let's plug in what sine is equal to. Sine is equal to opposite over hypotenuse. And I'm going to divide that by what cosine is equal to. That's adjacent over hypotenuse. And Masha, do you remember what I just said about when we have something divided by a fraction? What's that equal to? If I want to instead write it in terms of fractions, write it in in terms of division, write it in terms of multiplication.
You multiply it by the reciprocal.
Yeah, so what would this is saying opposite over hypotenuse divided by adjacent over hypotenuse. What would that equal?
Opposite over hypotenuse multiplied by hypotenuse over adjacent.
Exactly. Issa, do you see anything that cancels out here?
The two H's.
Exactly. And what are we left with?
Opposite and adjacent.
Yeah, and is that what tangent is equal to?
Yeah.
Yeah. So we're gonna call, these are our first three trig functions. These are our next three trig functions. Those are reciprocal functions. And this guy, I forget what it's called. I think it's called a quotient identity. But this is going to be our first identity. Okay, these are all part of the identities. But these are everything I highlight is something that we're going to need to memorize. Okay. And then of course that would tell us what about cotangent? What do we know that cotangent is equal to?
Adjacent over opposite.
Yeah, but what about in terms of sine and cosine?
Is it cosine theta over sine theta?
Exactly, because we know it's the reciprocal of tangent. And we could do a similar proof to this, but we don't need to. Okay, so this is kind of our tool bank so far of everything we're going to start to memorize. And let's take a look at some examples now. So let's start with the first big thing we're going to be asked to do is to find all 6 trig functions. And let's remind ourselves, what are the 6 trig functions? Can somebody list out maybe all of them, the ones that you remember? Of those ones we just learned, what are the 6 trig functions?
Sine, cosine, tangent, cosecant, secant, and cotangent.
Exactly. Okay. And I want to find all 6 of these from this triangle right here. Right? It's a right triangle, and we know its hypotenuse is 8 times square root of 17. This side is 8, and this side is 32. Actually, let's do it like this. I'm going to give you these 2 sides. I did spoil the answer a little bit, but that's okay. We need to learn one more equation, which I think you guys already know, and you can let me know if not. How do we find this side? I give you these 2 sides, and I'm telling you it's a right triangle. This is the last thing we have to memorize. You're not given an angle this time. We don't know an angle.
Pythagorean theorem.
Exactly. What does the Pythagorean theorem tell us? Let's call this side R.
8 squared plus 32 squared equals r squared.
Yeah, r squared equals 8 squared plus 32 squared, which tells us that r is the square root of that. And just a quick reminder, when we do square roots, this is technically plus and minus, but I'm only care about the plus because negative length doesn't make sense. Does that make sense what I'm saying? So just remember in math, if you're solving an equation, you have to remember that this is plus and minus. So if I square root both sides, I have to do plus and minus because I could put a positive in there or a negative and it will be the same thing because that's what it means to square something. But for length, we only care about the positive side. All right, can you plug that into a calculator and tell me what do we get? Square root of 8 squared plus 32 squared. Or better yet, let's do it like this. Let's figure out what actually is there. So we get square root of 1088. And we can simplify this to what? What numbers should we test to see what we could divide this by? I want to find the simplest fraction for this guy. How do we do that? Or the simplest perfect square. Have we heard, do we remember how to do that? So if I tell you, like, for example, square root of 20, what can you do with square root of 20? It's okay if you don't remember.
Divided by 4.
Yeah, right? Because 4 is the first perfect square. We're going to break up 20 into 4 times 5. And then this guy is a perfect square. It can come out. That could just be 2 square root of 5. So we want to do the same thing here. And that's okay if you don't know right away. Well, that divides by, whatever. It's okay if you don't know that. What would we test maybe? Maybe we would test
Divided by 2.
not 2, right? Is square root of 2 a perfect square?
By 4.
We could do 4. And we could see, all right, is it divisible by 4? It looks like it is. So we can definitely take out a 4. We could break that up into 4 times 272. But this guy looks like it's still an even number. We should see if maybe that one divides by 4 as well. So let's do 272 divided by 4. And all right, so now we know that 4 times 4 times 68 works. But this one also looks like we can probably divide it by 4. Let's see. It looks like we can take this guy and divide it by 4 one more time and then get 17. And of course, 4 times 4 times 4, we can see that that is 64, which is a perfect square. And what is the square root of 64?
8.
Exactly. So 8 square root of 17 is our simplest answer. I would recommend getting in the habit of this. A lot of teachers sometimes require it. But I would get in the habit of doing this and doing another thing, which we'll talk about in a second, called rationalizing. That's okay if you know what it is. If you don't know what it is, don't worry, we're going to talk about it right now. So let's start with, we know that R now is 8 square root of 17. Let's now ask ourselves, how do we find sine? Let's start with our first one. How do we find sine from this? What is sine equal to? What can we do to find sine?
Where's the angle that we were doing?
Well, let's ask ourselves first, we'll call it this angle right here. And then what do we need to know about our sine? What is the two parts? So the angle will be right here. So what's the opposite from that angle?
8.
So this is our opposite side. Here's our adjacent side. So sine of theta would be 8 over what?
8 square root 17.
Exactly. And before I talk about rationalizing, does this just right away simplify into something that we know?
Yeah.
Yeah, what does it become?
1 over square root 17.
Perfect. And there's nothing wrong with this answer. It is correct. But one of the kind of notation things that a lot of teachers really, really, really care about is called rationalizing. And if they ask you in the problem to rationalize, you have to do it. I would get in the habit of always rationalizing. What does rationalize mean? It means that if we have a square root on the bottom, we don't want that. We multiply both sides. I mean, sorry, not both sides. We multiply that fraction, the top and the bottom, both the numerator and the denominator, by square root of 17. Why do we do this? Well, 17 divided by 17 is 1, and anything multiplied by 1 is still the same thing. So we didn't change the answer. But what's nice about this is we multiply the tops together and the bottoms together. We get square root of 17 on top. And on the bottom, what happens when I do square root of 17 times another square root of 17?
It's the perfect square of 7.
of 17. Yes, exactly. And now there's no radical on the bottom, and we moved it to the top. Does that make sense? So anytime you're asked to rationalize whatever radical's on the bottom, you just multiply the top and the bottom by that same thing. I'll give you one. I don't think we'll get to it too much yet, but we might a little later. If you have, let's say, a plus square root of b, and this is now the thing you're trying to rationalize, you multiply this by a minus square root of b over a minus square root of b. So you do the same thing. You're multiplying by that radical. But if it's two things being added together, then it's two things being subtracted. If it's two things being subtracted, these get added. Does that make sense? You just do the opposite. Don't worry too much if you don't remember this. You won't need it yet. And when you do need it, we'll go over it a little bit more. Okay? I just want to introduce that in case there is a problem that comes up with that. But for the most part, if it's just one thing on the bottom, this is how you rationalize. Okay, so our answer would be square root of 17 over 17. Can we now do cosine of theta? And tell me, what does that become?
(32 over 8 square root 17).
I think that is correct. Let's see. So, first part sounds correct, right? 32 is our adjacent side over our hypotenuse, which is 8 square root of 17. Perfect. What do we do next? We want to simplify. So I'll let you know that we want to simplify and rationalize all of our answers. So what comes next?
Is it 4 over square root 17?
Yeah. So both divide by 8. So we get 4 over square root of 17. And then what do we have to do? What comes next? What did we do on the last part?
I forgot.
No worries. Issa, can you hear me? It looks, oh, there we go. Okay, sorry. It looked like you were frozen for a second. I wanted to make sure. Perfect. So on the last one, we radicalized. The bottom has a square root of 17, so we're going to multiply both the top and the bottom by square root of 17. And what does that equal? What happens when I do that?
It does it can't like undoes it. Like
Well,
17.
multiply the tops together. What does that become?
Wait.
Well, this is 4 times square root of 17, right?
Uh-huh.
So we can leave that like this for now. Does this make sense? At least just the top, right? We're just multiplying these together.
Mhm.
And then on the bottom, I think you were on the right track. But what happens when I have a square root of 17 times another square root of 17?
It undoes.
Kind
Like
of.
it
I mean, yeah, I think you know what it does. I think the proper wording would just be it's like a perfect square, right? We're doing this times this. That's the same thing as this squared, which gets rid of our, or undoes, like you were saying, our radical. And yeah, we're left with just 17. Okay, so this is sine and this is cosine. So those are our first two. Any questions on that so far? Give me a thumbs up if we're good. Awesome. Awesome. All right. Let's now do tangent. And Isa, what do we know about tangent with this problem? What is tangent going to be equal to?
A over 32.
Yeah, exactly. 8 over 32. That's our opposite over our adjacent. And that's going to be equal to what? What happens when we simplify that? how can we simplify that? Is there something? This is saying 8 divided by 32. Is there a way we can simplify that? Is there something we can divide this and this by?
Is it the same as 1/4?
Yeah, we could divide the top and the bottom by 8, and we get 1/4. Yeah, exactly. These are our first three trig functions. All right, let's now ask ourselves, how do we do the reciprocal trig functions? I want to find cosecant of theta. There's two ways you could do this. You can either do it by looking at our triangle, and we know that from our triangle, cosecant of theta would be hypotenuse over opposite. And we would say, all right, well, the hypotenuse is 8 square root of 17, and the opposite is 8. So this must just be square root of 17. The other way we can do it is we could say, well, I know that sine of theta was 1 over square root of 17. So what's the opposite of that? The reciprocal is just square root of 17. The reason I chose this one and not this one is what would happen if I did the reciprocal of this part? You can do it, and there's nothing wrong with that. That is going to be what cosecant is. But what happens when I do the reciprocal of that? What do we get? What happens when I flip that fraction, Masha? What would that be?
It would be 17 over square root of 17.
Yeah, and what's maybe the problem with this? Or why is that a better answer? So I'll give you a hint. Part of the problem, at least what I said, was I want to make sure that our final answer is simplified and rationalized. Is this a final answer?
No,
And why not? What's wrong with it?
because there's no square root on the top.
Well, you can have no square root on the top, but what you don't want is a square root on the bottom. That's unrationalized. To rationalize something means that we multiply the top and the bottom by that square root, and we would get 17 square root of 17 divided by 17. And then our 17s cancel out, and we get square root of 17. You can do it this way. I just recognize that, well, if I flip this one, that's going to be cosecant. Either way, it works. Whatever you want to do, if you want to just do it from this, or if you want to just flip it. Any questions on that? Give me a thumbs up if that makes sense. Okay. So then let's have Issa. Can you tell me then what would secant of theta be? And you could do it either way. You could do it either by just doing 1 over cosine or by doing by looking at our sides on our triangle. Up to you. But can you walk me through what we're gonna do?
Uh,
Mhm.
if wait, uh, wait,
Say it one more time. Mhm.
wait. If
So maybe let's start with the first step. How do you want to figure out what secant is? What do we know secant is equal to?
is equal to um hypotenuse over adjacent.
Yeah, we could do it that way. Hypotenuse over adjacent. Okay. So what is our hypotenuse and what is our adjacent side?
Uh, 8 squared 17 over 32.
Perfect. And what is that equal to?
Uh,
What do we notice about this 8 and this 32? Can they both be simplified?
yeah.
What do
Oh, yeah.
they, what do they
Is
both
it
divide by?
7? Wait, 17 squared over 4?
Square root of 17, but yep,
Oh,
over 4. Exactly. And we could see that that's the same thing as flipping this fraction upside down. All right, let's do the very, very last one. What about cotangent of theta? And then Masha, how would you do this one? Can you walk me through? How do we find cotangent? What do we know cotangent's equal to?
It would be adjacent over opposite, so you would do 32 over 8,
And what's that equal to?
or
Exactly, that would be 4. And of course, we know that this is the same thing as flipping this guy upside down. All right, so that's going to be um, our first kind of type of problem where we're given a triangle. The other type of problem is they're going to give us, so if we're given a trig function, what do I mean by that? Well, here's our first example. We are given that cosecant of theta is equal to 6. And we want to find all the other trig functions. Okay, well, let's start with, what does this tell us? What does cosecant of theta equals 6 tell us? What do we know cosecant of theta equals? So we know that cosecant of theta equals something. What is it equal to? In terms of our triangle we're going to draw.
like the reciprocal of sine.
Yeah, it's equal to the reciprocal sign, but what is it maybe in terms of the sides of our triangle? So if I call this one the opposite, this one the adjacent, and this one the hypotenuse, what does cosecant tell us?
That um the hypotenuse over the opposite side equals 6.
Exactly. Cosecant's equal to the hypotenuse over the opposite side, which must be equal to, and we can make 6 a fraction, right? 6 over 1. So let's label our triangle now. What can I call the opposite side? What value can I give to that from what we're told about cosecant?
1,
Yeah, this side must be 1. What about the hypotenuse?
6.
Yeah, and how do we find this last one that we don't know? We'll call this one x. How do we find what x is equal to?
Um,
If we're given two sides of a triangle that we know is a right triangle, what equation can we use to find that last side?
Pythagorean theorem.
Exactly. So, well, we know that x squared plus 1 squared has to equal 6 squared. So x squared must equal 6 squared minus 1 squared. So x must be equal to the square root of 35. Why? Because the 6 squared is 36. 1 squared is 1. So that's the square root of 35. So that's what we'll call this side. We'll call that square root of 35. Any questions so far? All right. Let's now very quickly, because I want to make sure we get to the next part, let's now just talk about how we find each of these guys. And from here, it's the same thing as what we did last time. We know that sine is opposite over hypotenuse. So that's 1/6. Cosine is adjacent over hypotenuse. That's square root of 35 over 6. We know that tangent is opposite over adjacent. And if we radicalize this, we get that this is equal to square root of 35 over 35. We already know cosecant. They told us that's 6. But we can figure out that secant must be 6 over square root of 35. And again, we can radicalize. And we would get that this is 6 square root of 35 over 35. And the very, very, very last one, which is cotangent, that must just be square root of 35. Why? Because I flipped this guy upside down. You can also flip this guy upside down and radicalize it. Or you can say, well, I know that that's adjacent over opposite. Give me a thumbs up if this kind of makes sense. Sorry to speed through that one. I just want to make sure we get to our last topic before we talk about homework. So let's take a look at radians. So the next thing we're going to talk about, section 3, is radians. Can somebody raise their hand if we heard of what a radian is before? Is this brand new to us? Let me know if radians are something we have heard before. And I'll tell you, well, let me know what you know about them. And I'm going to tell you that it has to do something with a circle. But what do we know about radians? What do radians tell us? What is a radian? Have we heard that before or no? Give me a thumbs up or a thumbs down if we have or haven't heard it. Isa, have you heard of radians before? It's okay if not. Let's talk a little bit about, so radians are just a different unit of measuring angles. And the most basic one that we know about is degrees. And I'll tell you right here, the very most basic thing to remember is 360 degrees is equal to 2 pi radians. Well, if we kind of take a look at our X and Y axis, and we call this guy theta, this is going to be called our standard angle. Our standard angle, anytime you're asked about a standard angle, the positive direction is counterclockwise. So if I had an angle of, let's say this is positive 45 degrees, this is positive 45 degrees. If I told you I have an angle of negative 45 degrees, then you go in the opposite direction. This would be negative 45 degrees. But you always start at the x-axis, and we call the side right here that makes up the opposite side of our angle, we call this the coterminal side. Okay, so this is the terminal side, and this is the initial side, and the initial side is always at the x-axis. At the x-axis, we have 0 degrees or 0 radians. These are just different units of measurement. You could think about it like degrees Fahrenheit and degrees Celsius, or inches and centimeters. They're slightly different, but they measure the same thing. So it starts at 0, or when we make a full loop all the way back around, we get to 360 or 2 pi. Right in the middle, or right up here, we call this guy 90 degrees. And that's the same thing as pi over 2 radians. Over here, we have 180 degrees, and this is the same thing as pi radians. That's 1 whole pi. And then the last big separator, and of course, what am I doing? I'm separating our quadrants. We know this is quadrant 1, quadrant 2, quadrant 3, and then this is quadrant 4. And this is just on our standard XY graph. And that last one down here, which we know is 270 degrees, that is 3 pi over 2 radians. Okay. All right. So let's say that I have radians and I want to get to degrees, or if I have degrees and I want to get to radians, we need to convert. So converting from degrees to radians, let's start with that. So if you're given degrees, so let's say we're given theta in degrees. So this could be like, let's say I'm given 90 degrees, right? All you do is you multiply that. So you multiply that angle by pi over 180 degrees. Why? Well, let's see. If I take 180 and I multiply it by pi radians over 180 degrees, the unit of degrees cancels out. And I'm left with 90 pi over 180. And what's 90 divided by 180? What does that simplify to?
1/2.
Exactly. So this is just pi over 2, which is what I told you was that conversion. So this is how we convert from degrees to radians. If you need to go from radians to degrees, very similar. The only difference is we take our angle that's in radians and we multiply it by 180 degrees over pi. So if I was given pi over 2, I would multiply this guy by 180 degrees over pi. My pi's cancel out, and 180 divided by 2 is 90 degrees. Any questions on that? Let me know if that makes sense. Awesome. All right. So let's do a couple examples before we run out of time. So let's do negative 135 degrees, and I want to find the angle in radians. So I take my negative 135 degrees, and I'm going to multiply this by pi over 180. Okay, well, the first thing we need to figure out is what can I divide both of these by? What number can both of these divide by? Can we think of the smallest number that both of these can divide by? Or the biggest number, if you could think of a bigger one.
3?
3, let's see, does 135 divide by 3? That could work. So they both divide by 3. So we can try that. So we could divide by 3, divide by 3, and we'll get, that would be negative 45 all over 60 with a pi on top. But does it look like both of these can divide by something? What can both of those divide by?
15.
Yeah, exactly. 45 can divide by 15 and 60 can divide by 15. So we'll get negative 3 pi over what? What is 60 divided by 15?
4.
Yeah. So we get negative 3 pi over 4. And that's our answer. Let's do a couple more. Can I have you two, and just give me a thumbs up when you're done. Let's do 45 degrees to radians, and then let's do 9 pi over 2 radians, 2 degrees. Let me know what you get for those two, and then we can get close to calling it for today there. And we'll talk about the homework. So it looks like you both got 45 degrees, right? Did we both get pi over 4? Perfect. Yep. And then let me know what you get for the next one. Alrighty, so I see Issa, it looks like you got 810, and then Asha, is that, it looks like 810. Let me know if that's what you got. Perfect. All right, so let's stop here for today, and let's take a quick look at, I'm gonna share my screen and just show the Google Drive real quick. So you guys all have a link to this Google Drive. Was there any issues accessing it? Give me a thumbs up if you were able to access it. Give me a thumbs up if you printed the stuff out that we need to print out. Awesome. So for today, you will go to this kind of table of contents, and I will post the lecture. It'll be a YouTube link, kind of like the Hopes class. If there is something that is confusing, you're welcome to watch her video. She did a very similar and great job as well. And then right here will be the concepts we're learning, and these are your homeworks. So 4.1, page 227, number 1 through 17 odds. So what is that? That's this guy right here. So you'll see the 4.1, and you'll do 1 through 17 odd. That's these guys. Then you'll do 19 through 26 all, and then 31 through 38 all. And you're just going to be using the trig functions that we were doing today. These are going to all be very similar to what we had already done. And then, yeah, then the only other thing is degrees and radians worksheet. This guy right here. You're going to do 10 through 17. So that's these guys down here. And then you're going to do number 1 through 6 of the extra practice, just these guys. Let me know, does that make sense? Any questions on that? Awesome. Well then, if there is nothing else, you're welcome to go. It was awesome meeting you, and I will see you all on Wednesday.
Thank you.
Thank you.
Have a good rest of your day.
You too.